Before we can think about the unit circle, we should be sure we all understand what a unit is. A particular amount of length, time, money, etc. that is used as a standard for counting or measuring. This definition gives us some freedom. We can define a unit as one of anything we want. That's exciting! How often does a definition allow you to make up your own definition? For example, we could define a unit as 1 inch, or 1 mile, or 1 earth radian. I like that. Let's use it and take a walk along this unit circle and see the sights. Hang on, there's one more thing our unit circle needs, some reference points. Let's use a Cartesian coordinate plane like this. Remember, we defined our unit as 1 earth radian, so our reference points look like this. Now I'd like to introduce you to Matt, the mathematician. He's a lot like you, a student of mathematics just learning about the unit circle and all the great things it can help him with.
Hey, I'm Matt, and I'd like to invite you to walk the unit circle with me. Let's start over here in the Atlantic Ocean on the x-axis at the point 1, 0.
Since this is the beginning of the journey, you've traveled a distance along the circle of 0 units, so we're also at 0 degrees on the circle. Matt, would you please walk toward the North Pole?
This is pretty cool. There goes Iceland.
From my point of view, as you walk, your path creates an arc along the circumference of the unit circle. The arc has an associated central angle which opens as you go. And you've arrived at the North Pole. Thinking about the unit circle, what do we know? First, the coordinates of your position in terms of the Cartesian plane are 0, 1. That means you've traveled 1/4 the way around the circle. How far have you walked?
It looks like I've walked 1/4 the distance around the whole circle, so that's a central angle of 360 divided by 4, or 90 degrees. I also know that the radius of my global unit circle is 1, and that the circumference of any circle is 2 pi times the radius. So, I've traveled 1/4 times 2 pi, or pi over 2 radians.
Nice work, Matt. Can you also calculate the values of sine, cosine, and tangent for your position at the North Pole?
Let's see. Using SOHCAHTOA, sine will be the length of the opposite side of my... Wait, there's no triangle here. What's up with that? Well, it seems a little unconventional, but I could imagine a triangle with a horizontal side of length 0 units and the vertical side of length 1 unit, so that's the x and y coordinates. The hypotenuse of this triangle is the same line as the opposite side. That makes sine equal to 1 over 1, or 1. Next, cosine of pi over 2 is the length of the adjacent side divided by the length of the hypotenuse, or 0 over 1, 0. And tangent of pi over 2 is... Whoops, there's a problem here. 1 over 0 is undefined. So the tangent of pi over 2 is undefined?
That's right. To summarize, the angle created by moving 1/4 the way around the circle in terms of radians is pi over 2. The sine of pi over 2 is equal to 1, the cosine of pi over 2 is equal to 0, and the tangent of pi over 2 is undefined. That's quite a lot of information. Well done, Matt.
What if I'd wanted to stop back in Spain for some tapas at 45 degrees from 0?
Can you find the radian measure, sine, cosine, and tangent for that position on the global unit circle? I'll give you a hint. Start by finding the fraction of the circle that you've covered at that point. Take a minute to work that out, then I'll go through it so you can check your work. It's a bit tricky, isn't it? Did you try drawing a triangle from your position? Did you remember that you can use the Pythagorean theorem to calculate the lengths of the 2 legs of the right triangle? Here's one way to work through this problem. Nice job! We're gradually building some useful information around the unit circle. Well, I think that's enough about the unit circle for now. Think about this though. Can we use this method to find the trig ratios for some other angles on the circle? If so, which ones? Give it a try.